I also want to say thanks to Professor Ujiana Secteria Pasaribu as a head of Statistic Research Group who support us in organizing this event. And I would like to welcome our invited guest, Professor Vincent from National Taiwan University of Science and Technology. It's Taiwan, right? And he is an adjunct professor and was proposed by the Statistic Research Group. Today, Professor Vincent will give presentations on the topic of innovative logistics service models and related optimization issues. I'm sure this topic will be very interesting for all of us and will motivate us to be able to work further according to our respective fields. As information, this event is sponsored by FMIPA ITB, and according to the latest information, there have been 70 people have registered with the following compositions. There are 6 practitioners, 29 students, 31 lecturers, and 4 from others. Okay, without further ado, I leave it to the moderator. Thank you.
Thank you for your speech,
Professor Vincent.
Mr. Sabto. The next speech is given by Professor Ujiana S. Pasaribu as the chairman of ITB Statistics Research Group. Prof. Ujiana, you are welcome to start.
Thank you, Professor Vincent, for that. First of all, that you give this talk in short time, because if I'm not mistaken, around a month ago, our group to ask you to have this webinar. Secondly, that you support us to do some joint research, particularly in statistic analysis correspondency, and also you already help us to open opportunity to have double degree in master program level, particularly with actuarial study program. And for information, Professor Vincent, around 3 days ago, we already talked with professor from your university that we will continue the idea to have double degree in actuary, and hopefully in next year we can fulfill that opportunity, and so student which is enter to actuary program can do double degree next year, 1 year in ITB and 1 year in your university. That is what I would like to convey to you, and sorry for not we can fulfill the program that actually me and Pasapto would like to visit your laboratorium sometime in 2 or 3 months ago, but since in ITB we have increased the level of the COVID, so we cancel. And now it's already slowed down, but the time is not good. It is the end of the year, usually, so very difficult to have air flight and also the permission from our government. That is maybe hopefully soon we can meet physically, not in visual. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you for your opening speech, Professor Ujiana. The seminar will be started after the next opening speech given by Professor Insinyur Wahyu Sri Gutomo as the Dean of Faculty of Mathematics and Natural Science of ITB. Professor Wahyu, you are welcome to start.
Okay, thank you very much. Good afternoon, everyone. First of all, I would like to express our sincere gratitude to Professor Vincent Yu from NTUST Taiwan. On behalf of the faculty, we would like to thank you for your willingness to visit us to give a webinar today held by the Statistics Research Group. And I also think that the topic you will deliver is very important to all of us in the light of the importance of comprehension on the innovative logistics service. And today we will have your lecture in this webinar, and I think of course that this will help our comprehension, and also this event will also provide some a bridge to the young students and researchers to have communication and contact, or even scientific discussion with you and with the others, talking about the logistic and all aspects that related to it, including how we treat the data, or maybe more or less it will be also related to data science in logistics, for example, and also the importance of and the usefulness of comprehending the logistic aspect, for example, in increasing the operational efficiency, improving forecasting capability, and also route optimization, and also improving delivery of products and other things, I think, that will be discussed in this webinar. So once again, I would like to express our gratitude to Professor Vincent, and also thank you very much to all the participants. Please have a good discussion here, and also maybe also the discussion of possibility to extend our collaboration, for example, that Professor Ria had said, and other things. Once again, thank you very much. Please enjoy this webinar, and officially I open this webinar. Thank you very much.
Thank you for your opening speech, Professor Wahyu. That concludes the first agenda. Dear ladies and gentlemen, as we know, the world is changing. As the digital world becomes more sophisticated, the world of commerce is also changing. Goods that previously could only be purchased at stores in malls or department stores can now be purchased with just a touch of finger on cell phone screen. This change has a huge impact on the world of logistics, because those who previously only delivered 100,000 orders now have to deliver millions of orders per day. This leap in demand for logistics service is a challenge itself, because if there are obstacles in the supply chain, it can have a fatal consequence for the world of commerce. A little example is when truck drivers in Canada closed the main road connecting Canada with USA. Earlier this year, for almost a month, due to this road closure, the delivery of auto parts was delayed. Manufacturers such as Ford, Toyota, General Motors were forced to scale back production or even close the factory entirely. From this example, we can see that it is critical for the logistics world to provide an efficient response to delivery service spikes, and when adverse situations such as strikes occurs, to help us understand the benefits of and offer insight on developing a better connected and smarter logistics service models. We are pleased to have with us today Prof. Yu of Industrial Management at the NTU of Science and Technology. He will also share how companies can improve logistics service to reshape and enhance the operation in areas of warehouse and supply chain management. Before the second agenda, which is a presentation by Professor Yu, let me briefly introduce him. Professor Vincent F. Yu is a professor of industrial management at National Taiwan University of Science and Technology. Professor Yu's educational background is that he studied and received his bachelor's degree in mathematics at NTU. Then he continued his education to the master's level of mathematics at Michigan State University, and Professor Yu continued his studies and received his PhD in Industrial and Operation Engineering from University of Michigan Ann Arbor. Professor Yu started his career in industry first, where he worked in the position of Decision Technology Manager from 1999 to 2004 at Conway Transportation Service, USA. Then in 2004, he moved into the academia world. His career in academia began when he worked as an assistant professor of logistics management at Kaohsiung First University of Science and Technology from 2004 to 2007. Then he worked as an assistant professor of industrial management from 2007 to 2011 at Taiwan University of Science Technology. Then he worked as an assistant professor of industrial management at NTUST from 2011 to 2014. And in 2014, he became a professor of industrial management at National Taiwan University of Science and Technology. Professor Yu's research interests include operation research, soft computing, logistics and supply chain management, energy system optimization, and artificial intelligence. He has published about 100 journal papers and 200 conference papers in these areas. Professor Yu has co-edited special issues for Computers and Industrial Engineering and Journal of Industrial and Production Engineering. He served as an editorial board member of the International Journal of Logistics, Research and Application as SCI, and academic editor of PROS 1 SCI and Journal Advanced Transportation SCI. Professor Yu currently serves as the president of POMS Taiwan. He is also a board member of the International Federation of Logistics and SCM System and the Operations Research Society of Taiwan. Professor Yu has collaborated with many leading companies in Taiwan, such as DHL Supply Chain, Foxconn, and Carry TJ Logistics. Professor Yu, received the NTUST Excellent Research Award 4 times, 2014 to 2015, 2016 to 2017, 2018 to 2019, 2021 to 2022, and the Outstanding Research Award 2022 to 2021. He also received the Outstanding Research Award from IEOM Society International in 2021. Professor Yu received World's Top 2% of Scientists Award in 2021, and that concludes my brief review. Now let's start the second agenda, which is the presentation of innovative logistics service models and related optimization issues by Professor Yu. Professor Yu, you are welcome to start your presentation.
Hey, thank you. Thank you for this introduction. Okay, and thank you for Professor Sato, Ujana, and Wayu, and Professor Yuri. Thank you for inviting me to have this opportunity to share my research with you. So let me share my screen first. Okay. Okay. I think by now everyone knows that I'm Vincent Yu from Taiwan Tech, National Taiwan University of Science and Technology. And today I'm going to discuss, actually today's presentation, the slides I use is for mostly for undergraduate students and probably first year master student. For undergraduate students, because we want to attract more students to study for logistics. Okay, so because of this, I try to make the slides more interesting. Okay, so there would be some videos in the slides, and also I try to reduce the amount of mathematics in my presentation. Okay, so okay, so okay, you already know my background. Okay, so so at this point, okay, at this point, my students and I are working on several projects, and we mainly in recent years we mainly work on issues related to city logistics. For example, the first one, this is a new project we just got from our Ministry of Science Technology. It's about how to integrate public transportation and existing vehicle fleet, and also crowd shippers to do city logistics, the last mile deliveries, especially in the cities. Okay, so so these are some of the problems that my group are working on right now, and you will see this later on during my presentation. Okay, and if I some of this interesting, maybe you can talk to me, talk to Yuri, or talk to my postdoc Panja here. Yeah, we will be very happy to share our research with you. But now let's start with today's presentation. So basically, there are three parts in my presentation. Okay, the first part is actually about the background. Okay, about why we are doing this kind of research. We are doing this kind of research because first, it is interesting. Okay, the research problems right now are very interesting, and also they are very challenging. In recent years, there are many new type of problems in logistics management, especially in the last mile distribution. And these changes are due to the rapid growth of e-commerce. Okay, and you know that there are many e-commerce giants like Amazon, right? Like Amazon. These companies, they can think out of box. Okay, so they will come up with many ideas the traditional carriers won't even think about. Okay, and because of them, okay, there are many new vehicles. Okay, new vehicles and many new operational models. Once you have these new vehicles or these new operation models, or even just new concepts, our distribution system would change. Right? And for us in the operation research, we will have many problems to solve because of this kind of new system. And the existing literature, the existing system won't be able to help us do the deliveries anymore. So we need to utilize the technique we have to solve these new problems. Okay, so the background. So the first part, I'm going to show you some of these new vehicles or new operation models, and they are definitely more than what I'm going to present here. Okay. And then I'll discuss some research that my research group are doing or we plan to do. Okay, and then I'll show you a little bit about what the future of logistics and mobility would look like in smart cities. Okay, and mobility is here because in the future, mobility probably will be will be combined with logistics, especially in cities. Okay, actually not only in cities right now, probably also in rural areas. Okay, when the demand is not that high, then we need to combine mobility and logistics together as a service. Okay, so these are basically the three parts of the presentation. Okay. So first, I'm going to show you some innovative vehicles and facilities. Okay, vehicles not just the trucks or the cars on the road. Okay, vehicle means the equipment we use to make deliveries. Okay, so by now you probably already seen some of this. We can make deliveries by robots. Okay, these little robots, they run on roadside, on the sidewalk. Okay, and they can deliver small packages or food to your doorstep. So when you place an order, okay, to the store, okay, they will use the robot to deliver your order to your home. And there are many companies already developing this kind of service. Okay. So for example, we can see one of these, Amazon's car. Right, this little robot, they can make delivery, but they have some limitations. Okay, they are on battery, so their range are very limited. Okay. And also there are some safety issues. Okay, for example, what will happen if someone just hijack your robot? Right, they will they will hijack your robot, and it's quite easy, right? If you have a van, you can quickly just put the robot into your van, then you can drive away with the robot and the goods in, right? Also, even if so, also for this kind of robot, because they are new, so people will be very curious when they see this kind of robot, right? Especially the kids. So can you imagine that when a kid sees the robot runs on the road, on the sidewalk, what would they do? They probably just kick it, right? They probably just kick the robot to see what will happen, right? Or to see if you will talk, something like that. So there are still some safety issues that need to be resolved. Okay, so so the first one is by Amazon, and then we also have China also have developed this little yellow horse. If you are interested, you can find videos on YouTube. And also Domino use robot to deliver pizza. Okay, in the US they use car. Domino in the US they use a autonomous car. Okay, self-driving car to deliver pizza. But in Australia they use a little robot to do the delivery. And this robot, like I said earlier, their range is limited. And their range is limited. So some Mercedes-Benz and Starship, okay, these two companies, they develop a system, okay, they develop van robot system, okay, and this van would carry a platoon of robots, little robots, to do the delivery. Okay, so they would go to a community, and then the van would drop off the robots. The robot would go out just to do delivery. Okay, several robots would do the delivery at the same time. Okay, and this this would make the delivery more efficient, and also they will resolve the issue about the range of the robot. You can see how they work. Okay, it's similar to the robot we just seen. So this van, they can host the robot, and then robot can get recharged in the van. Here you can see how they make delivery. So basically, it would be similar to have several delivery men in your truck. And for that, okay, the van can go to a community and then drop off a lot of robots to do the delivery. So it's like one truck and many delivery men. Okay, and for us, there are some very interesting and challenging problems from this little robot. And actually, for this system I just show you, the one with the Mercedes-Benz Starship. Actually, there's a paper in transportation science discussing this kind of delivery system. Okay, so these are very interesting, challenging problem, and if you can solve this problem and get very good results, your research work may be able to publish in top journals. Okay, and then let's see another new vehicle. This is actually not a new vehicle. This is like adding a device to your existing vehicle. Yeah, if you have an existing vehicle, they can add the device to your trunk. Okay, so when you are not home, okay, the delivery person can export a code, okay, from the back office, and then use the code to open your trunk. Okay, put in your packages and then close the trunk for you. Okay, so this way, even if you are not home, okay, they can still make the delivery. Okay, and you know that this is very important because if the delivery company, they cannot deliver your package, they need to take it back, and then they make a second delivery. If they cannot find you, then they probably need to do a third delivery. So they are double, triple their cost, right? So many companies, many logistics companies, they try to resolve this issue. Actually, at first, what they want to do is deliver packaging inside your house. Okay, so they will get the code, open your door, and then place your package inside your house. Okay, and actually, some companies are operating this way, but many consumers, they have concern about the safety, because even though you can have camera Yeah, you can see what the delivery person are doing inside your home. But sometimes it'll be too late. Okay, if they did something, and you just cannot stop them, right? So some people still have concern. That's why then they come up with this trunk delivery, okay, delivery to your trunk. And again, there's a very good paper published in I think it's also transportation science about this kind of delivery. Okay. Okay. And then we know that right now, or maybe every country is trying to develop the actually have developed the electric vehicle policy. Okay, they are going to drive the the conventional vehicle out of the market. Okay, so some country maybe they won't sell the fossil oil driven vehicles at 2030, some 2035, some 2040. Okay. Anyway, this is trend. Okay. In the future, you can expect that all the delivery probably will be made by electric vehicles. Okay. And to us organization people, what does this mean? Okay. In the past, you plan the trip, you plan the routes for the conventional vehicles, right? You don't really need to consider where the vehicle is going to refill, right? Because the gas station is everywhere, right? And usually the conventional vehicle, their driving range is very long enough to support the daily operation. Yeah, but when the electric vehicle just come out, okay, they also have limited range. So you need to consider, and there are only few places that offer them to recharge, right? So at the very beginning, when we planning their deliveries, we need to consider where they can get recharged. Okay, so this bring up some really interesting problem. So right now, a lot of people are working in this area. Okay, basically all the problem we solve for conventional vehicle need to be resolved for the electric vehicles. Okay, yeah, but although this has become a hot area in this largest research, I feel that some of the research may already been obsolete already, because the technology advanced really fast, and now the range of electric vehicles are like 600 kilometers, 700 kilometers. That's long enough to support daily operation in the cities. Okay, so but still a lot of people still working in this area, but I'm not sure if this is really practical anymore. Okay, but anyway, if we are interested in this kind of research, this is definitely a good but very crowded research area that you can explore. Okay. The next one is parcel locker. Parcel locker. For parcel locker, these are not vehicles anymore. These are new facilities. And I don't know if you should also have this kind of parcel locker in Indonesia, right? Yeah. So in Taiwan, in the two in the middle are used in Taiwan. Anyway, the one on the top, the green one, is used by our post office. Okay, the one, okay, in the bottom row. Okay, I think that one is out of business already. Okay, because that one actually came out earlier than the one with used by post office. So so basically with this it's called iBox. With this parcel lockers, instead of make delivery to your home, okay, they can deliver your package to parcel locker and then send you a code. Okay, you can use the code, okay, whenever you want to open the locker to get your package. Okay, so again, the largest company, right, they don't need to make second delivery or even third delivery, because the parcel locker is usually operating 24 hours a day. So they can deliver to the lockers anytime, and you can retrieve your package anytime. Okay. So it's also a very convenient way to both parties. Okay, it's beneficial to both parties. Okay, but again, with these parcel lockers, okay, then you to decide how you can make deliveries more efficiently, right? So some customer may ask you to make delivery to their home. Some may prefer to have their packages delivered to parcel lockers. Okay, and some may say, okay, if I am home, you deliver to my home. If I'm not home, then you deliver it to the parcel locker. Okay, so there would be, so in the past you only have one type of customer, right? Make delivery to their home, but now you have 2 or 3 type of customers. Okay, then you need to decide how to make deliveries that's more cost efficient to your company. Right? Okay, so there are again many challenging problems, and our group has done some research in this area and have published several papers. If you are interested, you can look at my publication list, then see read our papers and see if this is something that you want to work on. Okay. And this is the parcel locker. They work. I'm not sure if the convenience store work like in Indonesia, work like the ones in Taiwan. Okay, in Taiwan, we can pick up our package from the convenience stores. We can send our package at the convenience stores. Okay, so basically, right now, all the convenience store they have rack behind the counter. Okay, with a lot of packages. Okay. So basically, their function is now very similar to parcel locker. So you see in this figure, okay, first seller can send their parcel to the nearest post office or 7-Eleven, right? And then, okay, the truck, okay, 7-Eleven or post office, they have their own fleet of trucks. Okay, they can deliver, they can move to the packages to another 7-Eleven or another post office, where the customer can go there to pick up their parcels. Okay. So this is basically how the system with parcel lockers work. Okay. And then there are also new concepts, and these are again new vehicles, delivery by airship and drones. And you probably have seen drones a lot already, right? Drones, but airship probably not. So originally, people think that you can make delivery by drones, but and so but there are many ways of utilizing drones. in your delivery system. Okay, and this is the simplest one. Okay, you place an order, then from the warehouse, they send a drone and deliver to your balcony. Actually, yeah, yeah. But okay. So this is the simplest system. Okay, and then the system becomes a truck drone system. Okay, a truck carry a drone to do the deliveries. Okay, the truck will stop at somewhere, some point, and then they would dispatch the drone to make delivery, and then they would stop at another location to receive the drones who finish the delivery. Okay. And there are many types of drones, but I think I will skip this. Okay. Just skip the videos. You can find different type of drone from YouTube or other channels. Okay. Oh, this one actually, I'm not sure if this really work in Indonesia. Maybe you can tell me. This is the although I saw this, but I'm not sure if it actually works in Indonesia. It's JD, a Chinese company. So this is their system of utilizing drones, okay, to make delivery to rural areas, the villages. So do you have this in Indonesia? Does JD use drone to make deliveries? I'm not sure if you really have this, or it's just a demo. But anyway, you know the concept. You know the concept. Okay. And this is the airship. Okay, this actually has Amazon actually filed a patent. That's a patent for this. Okay, in the 2014. Okay, they filed a patent. Okay, using this airship and drones to make delivery. And basically, okay, they use this. They have big airship.
Delivery drone. Amazon's airborne fulfillment centers would hover to 45,000 feet and be the focal point of a network of unmanned aerial vehicles. The
So this airship can carry a lot of packages and a lot of drones. And when the drone finish delivery, it can come back to the airship to get recharged. And it can also have smaller airship to replenish the big airship.
only came to life last week. Amazon has successfully tested delivery by drone in the UK and is waiting for federal approval to roll out the service in the United States. Here are some more stories about it.
Okay, so you know the idea. Actually, my students, my undergraduate student, they actually uh, solve a problem, okay, solve a delivery problem with airship and drone. Okay, but what they did is very similar to the problem with truck and drone because airship, basically they can release drones anywhere. Okay, they they are not like vehicle. They can actually release drone whenever they want, and drones can come back anytime. But it's just too difficult to solve. So in the end, the undergraduate they solve the problem that the airship has it's a fixed tool. Okay, has its fixed tool. Yeah, they cannot fix tool. They can stop at certain locations. Okay, they can choose some location to stop and release drone. But I think that research still have a lot of room to improve. Okay. Okay, and this probably have seen already the Kiva, right now. Most of the new warehouses are using this Kiva system. Okay. I'll show you, but I don't know about you. Have you seen this kind of system in reality? Okay, right now all the new warehouses are built using, yeah, almost all of them, okay, are built using this kind of system. Okay, I'm not talking about those warehouse with ASRS, okay, with those tool racks. No, that's a different purpose of warehouse. Okay, I'm talking about the warehouses of the e-commerce company. Okay, where they need to frequently pick orders. Okay, pick orders, and in those kind of warehouse like Amazon warehouse, okay, they use this. They need this kind of system to improve their efficiency, picking efficiency. Okay, but actually at the very beginning, I feel that this kind of system has some bad impact. You see, because in the past, we put the products on the racks, okay, at fixed locations, okay. And when you are picking order, the step will just find the product, okay, find the rack, find the product, and then pick the order, okay. That one, of course, is not very efficient, right? Not very efficient. So later, they probably will pick several orders together, okay, and try to improve efficiency. Yeah, but no matter what you do, okay, the efficiency is just cannot compare to the efficiency of this Kiva system. Okay, yeah, I have to admit it. But for the Kiva system, okay, yeah, if you need one product from a rack, this rack will have to travel probably a long way, right, to the picking station, right? And then you retrieve one product, and this rack will go back to get in line, or go back to somewhere to wait for another order, right? So you can see that for one product, you need one product, but you need to move hundreds of products with this product you need. So you are wasting a lot of energy. Actually, yeah, there's trade-off, right? You waste a lot of energy, yeah, but your efficiency will be enhanced. Okay, so actually this is not good for the environment. Not good for the environment. So this system, I think it has some drawback. But at the very beginning, people are fascinated with this new tool, but no one think of these issues. But now, gradually, some people have seen this, and then I don't know, maybe we'll have new system in between to improve the while improving the efficiency, also reduce the negative impact of the environment. Yeah. But maybe you can think of something to improve this system. I think this system is not very good for the environment. It's the same for the production system we have right now. Yeah, global production also wastes a lot of energy. Okay, increase a lot of emission. Yeah. So I'm glad to see that right now, many country they try to produce products locally. Okay. Yeah, of course, producing your product in Indonesia, Vietnam, China will save cost, right? But moving from this Asian country to European or North America will waste a lot, cause a lot of emission. Yeah. So, but no one really calculate the impact of this kind of production system. Okay. So those are new vehicles and new facilities. Now we are going to look at some new operational models. The first one, night delivery. Night delivery. We know that trucks, the delivery trucks, they cause a lot of problems in our transportation system, especially in the city. They will cause traffic jam, right? And the drivers, because they need to make deliveries in time, so they tend to drive really fast. But due to the limit of in the visibility of the trucks, okay, sometimes they cannot see the pedestrians or see other small vehicles, and then the accident will happen. Okay, so they have safety issues. Okay, they have the congestion issues, and then they also have the emission issues, right? So truck actually trucks are not very good. Okay, but we need them. We need them to make deliveries, especially now with this e-commerce, especially in the last 2-3 years. Okay, many people buy everything, almost everything from e-commerce company. Okay, and people won't go out. They will just sit in their home waiting for the delivery. So we need these trucks, right? We need these trucks. But how do we relieve the negative impacts of these trucks? Okay, one way is because we have more traffic in the daytime. So one alternative is trying to move the truck. Okay, move this truck to evenings or midnight. Okay, when there are less traffic. Okay, and then their impact would be smaller, right? So there are many benefits of moving this truck or making night delivery in the evening. Okay, the only problem in the past, the most serious problem is that, okay, people don't want to receive packages in the evening, right? Especially, okay, but those families with little kids or elderly people. If you make delivery in the evening, okay, the elderly people probably cannot sleep anymore, right? and the babies, okay, they will be woke up and then they will cry, right? So in the past, yeah, people probably cannot accept this kind of operational model, but now they can. Why? Because you have parcel lockers, right? You can move the package to parcel locker in the evening or to the convenience stores, right? And also in many, if you live in a city, okay, and you live in a large community, your janitors can collect the package for you. Okay, so all of this make this operational model possible. Okay, so this is I think it is a very good alternative to relieve the negative impact of trucks. And with so for us then you need to decide what are going to be delivered in the evening, what are going to deliver in daytime, right? So again, there are new optimization models issues in there. Okay. Okay, and then ride sharing. Okay, what I'm going to discuss a new operation model where we use taxi to deliver goods. Okay, well, we already know this ride sharing, right? People can share a taxi, right? People can share a taxi. But in the past, okay, we only share taxi with other people. But the new concept is we can share the taxi with packages. Okay, and this problem is called the share ride problem. Share ride problem. Okay, so if you have some people have package to deliver to, and some people, okay, are going to take a taxi to somewhere. Okay, so they can all get in the same taxi. Okay, the package and the people can get in the same package, and then this taxi, okay, while these people still in the taxi, they can make delivery. Okay, okay, and then they reach their destination. Okay, so this is just one of the possible model. Okay, I have reviewed a proposal several years ago. Okay, that group of researchers they proposed another model. Okay, because some people probably don't like to wait for the driver to pick up packages or make deliveries. Partly because it will increase their time in the taxi, right? Although they will get some discount, but some people they take taxi because they are in a hurry, right? So the other model is that they don't make deliveries or pick up packages while they are passengers in the taxi. They will do it when they are no passengers in the taxi. Okay, so that's another model. But either way, these are new models. Okay, especially when you combine these taxis with your own fleet, own trucks. Okay, then the problem can be very complicated, and then also very challenging and interesting. I think these are very good research topic, especially this share ride problem. Basically, you have two type of product if you treat the passenger as a product. So you have two type of product, okay, in the taxi. So this is very similar to the classical dial ride problem. Dial ride problem, okay, you call the company, tell them that you need a ride from somewhere to another place, and then again that bus or van, and they would take several requests, and then they will just drive you from your origin to destination. This is called the direct ride problem is trying to optimize this system. Okay. So for this problem, this actually is a two commodity direct ride problem. The direct ride problem with two type of commodity. And if you treat, if you feel that the passengers are more important than packages, and then your problem become a two commodity direct ride problem with priorities. Okay, so direct ride problem is a classical problem. So there are many different variants. Okay, so the shared ride problem can be developed into many different type of operation models, different type of problems. So this is actually a very good research area. Okay, but not many people are doing this right now. But recently, one of my friends just published a paper using electric vehicles and conventional vehicles in this shared ride problem. And the paper also published in a very good journal, Transportation Research Part E, I believe. Yeah, so so this is a good area if you are interested in this kind of research. Crowd shipping. Okay, crowd shipping. Panja have done a lot of crowd shipping. So recently, crowd shipping become very popular. Okay, and by crowd shipping, we are not talking about those crowd shipper who are almost professionals, right? Those drivers for Panda, Uber Eats, yeah, they actually are like employees of the company, right? But I'm talking about those occasional driver. They only make some delivery on their way to work or on their way to home. So they probably only deliver one package or two packages a day, and not every day. Okay, so the crowd shipper, they would go somewhere to pick up the package, okay, from the largest company, and then okay, they would help the company to deliver the package. Okay, probably if they are on their way to work, they go to the company to pick up the package and make deliveries up to somewhere near their company, right? And then they probably get a little bit of compensation, probably not very much, yeah. But since he or she need to travel, so it doesn't really affect his travel in any way. So we are talking about this kind of crowd shipper, and there are other type of crowd shipper. For example, if you go to a store to buy, for example, you go to supermarket to buy some groceries, and then when you are at the cashier, and the clerk asks you if you can help them make delivery to your neighbor, because your neighbor place some order online, right? And do you want to do it with some compensation? Yeah, of course you probably will do it, right? Because you are going home anyway, right? So this is another type of crowd shipper. Okay. So you can see there are many advantages of utilizing crowd shipper. Okay, we can utilize available vehicle capacity and lower distribution costs. Okay, we can reduce emission impact of freight vehicles. Okay, and then we can eliminate excess distance travel, delay, and facilities. Okay, however, there are some issues with this kind of delivery. Okay, including the share ride problem we just discussed. Okay. The first thing is that and illicit products. Okay. We don't know what's inside the package, right? Don't know. The professional company, the largest company, they probably have some way to examine their packages. But for us, cruise shipper, we don't know. So if someone put some drugs or some explosive in the package, yeah, there's no way that you know it, right? Yeah. And then you become an accessory, right? So, and another challenge is the traffic congestion during rush hours. This is especially true for the food deliveries, right? You see, during lunchtime, dinner time, okay? A lot of people want their lunch or dinner delivered in time, right? So the food panda people or the Uber Eats people, they will try to drive faster to deliver your food, and this again cause a lot of traffic, right? Traffic congestion, and then most importantly, may cause some accidents. Yeah, because they try to deliver your food in time so that you will give them 5-star, something like that, right? Okay, and then with this crowd shipper, okay, the route planning become very complicated. Yeah, because you are so in the past, one truck, one route would deliver probably hundreds or couple of thousands of packages. Now every crowd shipper deliver one package, so you need to deal with maybe 100, couple thousand different routes, different origin definition pairs. So this route planning become really complicated. Okay. However, I think this is a very good operational model. Okay. For the packages, for the food, actually I'm against using crowd shipper to deliver food, because there are a lot of accidents caused by food delivery. Okay. So next time when you order food online, think about this. Okay. Okay, so these are the new operation models, and earlier we discussed some new vehicles.
Secret number.
New vehicles and new facilities. Okay, so you can see that with these new changes, okay, new models, new vehicles, new facilities, the problem we will have bunch of new problems. Okay, and these problems are actually quite interesting, but also very difficult to solve. No, I shouldn't say very difficult, very challenging. Okay, because they are much more complicated than the conventional models. Okay, but this is why this world needs people like us, right? Because they are complicated problems. So the world needs us to solve these complicated problems. Okay, so this is basically what we do. Okay, so now I'm going to discuss some of our recent research. Okay, I've seen this, right? I have talked about this. Delivery by drones, delivery with parcel lockers and airship and drone. Okay, yeah, I used to have mathematical model here, but then I decided to remove them. I just tell you how we do this in general. Okay, okay, let's just take one problem, show you the step needed to do this research. basically in this problem, okay, we have a fleet of vehicles. Okay, these vehicles are not the same, heterogeneous vehicles. Okay, they probably have different speed, different capacity. Okay, anyway, their characteristics are different. And then we use this fleet of vehicles to make deliveries, and we also use drones to make deliveries. And instead of having a single drone, we use multiple drones. Okay, and the factor we consider are, okay, we want to minimize the energy consumption, we want to minimize completion time. Usually for this type of problem, we want to minimize completion time. And in some problem, they will consider energy consumption. So the step for doing this kind of research is that we need to develop a mathematical model. Okay, develop mathematical model. I'm not sure if you have taken courses on optimization or operation research. Basically, for this type of problem, we need to model them as a linear programming problem, integer programming problem, actually, integer programming problem. Sometimes linear, sometimes non-linear, depends on your problem. For example, if you are dealing with electric vehicles, okay, then you probably need to develop a linear model because the recharge, okay. So we need to develop mathematical model, then we solve the test problems we call instances test problem using commercial solvers, or we develop heuristic or exact algorithm to solve the problem. Okay. And the same for the partial lectures. Okay, I will come through this. Again, you can see develop mathematical model and use commercial solver to solve test problems, and then develop heuristic algorithm or exact solution approach to solve them. Then why do we need to solve the problem by commercial solver and then by algorithm, by heuristic algorithm? The reason is that for these integer program models, usually they are very difficult to solve. Very difficult to solve. Even though you have commercial solvers, you probably cannot use them to solve problems of realistic size. Those problems that can be used in practice. Okay, so there are limitations on the commercial solver. Okay, and they cannot solve large problem, and they tend to be much slower than the heuristic algorithm. And that's why, okay, you after you develop a model and you use commercial solver to solve it, you still need to develop heuristic algorithm so that you can solve large problem. Okay, problem that probably are closer to the practical problems. Okay. And also because the commercial solver, okay, when the problem size gets bigger, okay, the computing time, computational time grows exponentially. Okay, really slow. Okay, so for practical problem, for example, food delivery, they need to make a decision within seconds. Okay, you expect the food on your doorstep within 5-10 minutes, or if you call Uber, right, you can only wait like 5 minutes, right? So a lot of quick decisions need to be made, so we cannot wait for the commercial solver. We need to develop heuristic algorithm that can solve the problem to near optimal solution in a very short time, especially in today's world. Okay, speed is very important, and that's why, okay, heuristic algorithms, okay, are actually, in my opinion, much more important than the models. Okay. If you you want your problem can be applied to real world situation. Okay, let's skip this. Okay, so these are some of the papers that recently published papers done by our research group. Okay, and some of them are by Pancha here. Okay, so if you have a question about the paper, you can ask Pancha. Okay, and you can see that we focus on city logistics, right? So in 2020, we have this this model that we consider two echelon freight distribution system in urban area. Okay, and in this problem, we have loading and unloading zone where the truck can park in these zones. Okay, actually, just sometimes just a small parking space. Okay, the truck was with temporary park there, and a lot of crowd shippers or delivery person. Okay, we could just go to the truck to take their package and then make delivery. So this is what we published in 2020, and then Pancha published two papers also. The first one was the
Belum ngecek lagi.
distribution system.
Udah disetujui?
Okay, and then he also considered, you see, cover and location. Cover and location is very similar to the parcel lockers or the 7-Eleven. Okay, and occasional driver, and these are the crowd shippers. Okay, these are really okay. They only take package occasionally. Okay, so these are really, these are the true occasional drivers. Okay, not like those people for Uber Eats or Panda. Okay. Okay, and then later he has a paper on crowd shipping problem with time window, transshipment nodes, and delivery options. Okay, so delivery options like what I just discussed. When you use parcel locker, you have the customer have different delivery options, and the transshipment nodes are like a facility that where the truck can where actually where the should be the truck can go there to actually it's something like a consolidation center, right? But it's smaller, right? Where they can exchange goods there. And then later we have this vehicle routing problem with simultaneous pickup delivery and occasion driver. Again, we focus on the occasion driver. And then most recently we have one with about general the share ride problem. Share ride problem, we release some limitations about the capacity, okay, and become a general share ride problem. And then instead of have single depot, we consider multiple depots throughout the city. Okay, so these are the recent research that we have published. Okay, and I think these I put them here because I think this problem has a potential to be developed into a rather comprehensive system. Okay, different problem for different occasions. So if you're interested in this kind of research, you probably can read these papers and then see if you can come up with a new concept, new model, and new solution methods. All right. So far we have gone through the new vehicle facility new models. That's the background of our research. Okay, why we do this kind of research. And then I discussed some problems that we have done or we are doing. Okay. So I don't know if you have questions so far, because this I'm almost done with the main ideas of this presentation. And later I'm going to show you some new concept, and from those new concepts, you probably can come up with some new models. Okay. Or probably you can develop some new models for new problems. Okay. Interesting problems. Okay, no, then I'll go on with this. This will be the last part of my presentation. So in this part, we're going to discuss some even more innovative logistics or mobility services, okay, or for vehicles or facilities. Okay. And this can be connected to smart cities, because for this kind of system to work, okay, we need the infrastructure in smart cities. Okay. Otherwise, they cannot work. Let me show you this. Okay. This is actually quite interesting concept, and some companies in Taiwan are now working on this type of smart platform or smart bus stop. Okay. I'll show you the video, then you can see the concept. Some are not that innovative, but some are new and can especially some of them are related to logistics and can bring up a stream of new research topics. Let me show you the video. So this smart bus stop with many different functions. You can see that there's parcel delivery function. You can see the lockers here. And social junction, actually, I don't really know why you do social activity at bus stop. Okay. So you can see that actually all of these can be realized. They are not so difficult. Okay. So you can see that almost all the functions can be implemented with today's technology. They are not that difficult, right? So some companies in Taiwan already already work on this for some time, and I think actually the bus stop here already have some of the functions. Okay, already have some of the functions. Okay. For example, you can see the bus information, arrival information, the buses now, right? Almost at every bus stop. And the solar panel, that's easy, right? And parcel locker also easy. So everything can be done. Everything can be done. Okay, just see if you can put them nicely in the pasta. Okay, but with this kind of pasta, okay, especially this pasta have partial lacquers, then you can actually utilize buses to do delivery, right? And your crowd shippers can take buses. Okay, they can take the package from parcel locker, take the bus to the destination, get off the bus, and put the package in the parcel locker for you to pick up, right? So these are so with this system, we can actually use public transportation, can use crowd shipper to do deliveries in a smart city. So it's like this, right? We already know that in the in Taiwan, okay, in Taiwan, we can actually check in at the metro station. When we are going to take a flight, we can check in at metro station and then check in our packages there. Okay. The metro line going to airport, okay, going to airport can take your package to the airport. Okay, you can get on the the train. Okay, you can get on the train, and your package will be in another compartment. Okay, but you can check in before you get on the train, before you get to the airport. Okay, so so basically, using train, metro train to deliver packaging is feasible, right? If when you build, of course, if you already have an existing system, this probably won't work. Okay, because there's no way that I can build a new conveyor, right, to move the packages. But if you are building a new metro line, okay, then with this concept, then you probably can put in a conveyor, okay, at the compartment for at the train for packaging, right? So if you still have time, then when you are building a new metro, then you can consider this, and in the future, you can make delivery by your metro line, right? So so basically, this I just show you that this is feasible. We can check in package at metro station. Then with the smart bus stop, okay, this is what we can do. We have package at the warehouse, okay. The bus can pick up the package, right, and then go to the smart bus stop, drop off the package at the parcel locker there. Okay, the customer can go there to pick up the packages, right? So if we have that the smart bus stop, this can be done, right? And actually can be more complicated, right? You can actually go to the bus stop to drop off your package. Okay, you can put in the parcel locker, right? And the bus will pick it up, move it to another bus stop, and drop off the package at the parcel locker there, right? So they don't even need to go to warehouse. You can send your package at the bus stop. And better yet, with metro, okay, with MRT, then actually in Taiwan there are many parcel lockers in MRT station. So when you place an order, the seller can send the parcel to the nearest MRT station, the parcel locker there. Okay, then the MRT can move the package to another MRT station, okay, where you can go there to pick up your package, just like bus, right? Or we can combine them together, right? You have buses, you have metros, metro, MRT, trains, okay? We can all work together, okay, to move your packages throughout the city, right? Okay. And then, okay, so up to here, okay, up to here. And I don't have the truck here, okay? So up to here is what we are doing right now. Right? We have a new project from the Ministry of Science and Technology. The project is about, okay, that's the first project I show you when I start this presentation, how to integrate public transportation to do the last mile delivery. Okay, so this is what our new project is about. Okay, so the project starts in this August. So starting from this August, we are going to work on these different models for 3 years. Actually, this is the third project. We have in the past we already have 2 3-year projects. This is the third year project. So we spent 9 years working on this system. Okay, these the optimization models for an algorithm for the new logistics system, especially the city logistics. And now we are preparing another proposal for that's the one shown here. Okay. Now we are trying to integrate drones with the public transportation system to make deliveries in smart city. Okay, so because the drones they have limited capacity and limited range. So if you want to use drone to make delivery from this side of the city to the other side, okay, they probably cannot fly there. But with the help of buses, I don't know about metro, okay, with buses, probably metro can do it also. The buses, okay, the drone can take a bus to somewhere, okay, near the destination, and then took off to make delivery. Okay, after the drone make delivery, it can come back to another bus where it probably can recharge, okay, and probably can take parcels from the bus to do another delivery, right? So this is a rather new problem, okay, rather new problem. We don't see many publication on this operational model. So I think there's still a lot of potential in this area. Okay, so if you are interested, this could be a special method to students looking for a research topic, or the undergraduate students looking for a topic for your project. I think this would be a very nice topic, very new and challenging. Okay. Okay. So this is a more complicated model, right? Everything, put in everything. We have bus, we have metros, and we have parcel lockers, right? And then we have drones. Okay. So putting everything together to make our city logistics more efficient and cleaner. All right. So I will skip this one because I don't. This is quite interesting. If you want, you can watch the video on YouTube, but I don't think this can be realized. This on the left hand side can be realized. The one on the right hand side, the capsule system, cannot be realized. My opinion. I'm going to show you this. I think this is the future. Okay. Yeah. because the vehicles will be connected in the future, right? With the ICT technology, vehicles going to be connected. So in the future, the trucks are going to okay, trucks going to be of course will be autonomous trucks, okay, self-driving trucks, okay, and they are going to be protoned, just like train, yeah, but they can decouple at any time. So in the future, probably we don't need probably some function of the consumption that will be replaced with this, the one in the middle. Okay, we still have some time. I show you the video. This is by Volvo. You can see that they can change trailers while they are driving. In the past, we do this at the consumption center, the hubs.
City public transportation. The silent emission-free buses bring public transport closer to people, even drivers. This opens up new opportunities for city planning. Past the efficient way of charging from electric grid, the end terminal just a few minutes. How do we build cities and the infrastructure of tomorrow in a more sustainable way? The future zero emission is the electric excavator access environmental zones in the city. Imagine a silent emission-free city. Imagine a cleaner, safer, more resource-efficient world. Without confidence, between life and health. The future is now.
Okay, so this is the concept from. Actually, I don't think this is just concept. I think this can be realized in near future. Okay. So basically, you can see that instead of having the instead of changing the trailer, changing the goods at the consolidation center at the hubs, we probably can do it. Okay. Do it on the road, and this way we reduce the need of large hubs. Large hub actually when you do consolidation at the large hub, it's very time consuming because a lot of synchronization are needed. You need to wait at the dock at the platform, waiting for the other truck to come, and you can start a consolidation. It's quite time consuming and need a lot of space. And during the peak seasons, you just don't have enough space to accommodate all the trucks, all the packages. So this would be a very good solution to consolidation for freight delivery. I'm talking about long haul delivery. And you can see that this truck, the truck will be electric truck in the future. Okay. And Tesla already delivering the electric truck to its clients already, right? So this definitely will be realized. Okay, the last one. Okay, that's one. Yeah, you can see that the reason that I put mobility and logistics together, right? You can look at the problem we study. Okay, we use bus, right? We use buses, and we use metros, we use taxis, and people and packages are all on these vehicles, right? So that's why in the future we need to put mobility and logistics together. Okay, we cannot just consider mobility alone or consider logistics alone. Okay, there will be one entity in the future. Okay, so the last one, this one is very interesting, and I share this video, and then then we can conclude today's presentation. This is also a new concept. I show a short version. Let me show you a short version. This is a multi-function. Multi-function vehicle into ride sharing and become hospital shuttle and deliver lunch. And it can become an office, and it can also become a showroom. Okay, it's a multifunctional vehicle. There's a longer version, about 5 minutes. And if you are interested, you can watch the video on YouTube. And they can also become logistic vehicle. Again, controlling. Right. So coupling and decoupling just becomes so easy. And then you can just do mobile consolidation. Actually, I think mobile consolidation is a very interesting topic. Probably very difficult. I think very difficult because if you can consolidate anywhere, okay, the problem is very difficult. I think it's a very good research topic and have very practical use. Yeah, I think these are not difficult nowadays, right? Facial identification, right? And right now the package can actually follow people, right? So I don't think these are difficult to realize. So I feel that sooner or later we'll see this kind of system. So this would be the end of my presentation, and I hope you enjoy this presentation. I try to include some video to make it more interesting instead of introducing a lot of mathematical model. I also try to, during the presentation, I also show you some potential topic that if you're interested in this area, you probably can work on them. Okay, and I hope if you have any questions, feel free to contact me or Pancha. We will be very glad to discuss with you. Okay. Okay, thank you.
Thank you for your insightful speech, Professor Yu. Your presentation was especially helpful to those who are interested in logistic world but don't know where to start. Dear ladies and gentlemen, right now we enter the third agenda, which is the Q&A session. Please, if you have any question, may you raise your hand with the emoticon button of Zoom and talk directly with Professor Yu, or send your question via chat. Due to the time constraint, the number of questions is limited to 1 to 2 questions only. If you want more information, you can contact Mr. Yu email. Okay, Mr. Yu, there's a question. My name is Putuhari Gunawan from Telkom University. He is interested in model of smart bus system. As he catch from your presentation, the input data of the smart system is real time. So what kind of model is used in the smart bus system to make a fast decision, sir? Is the model improved in real time based on input data? And how many variables are used in this smart bus system, and what is the difficulty? Thank you.
Yes, thank you. Smart bus system. I'm not sure. You're talking about the system using bus to make delivery, or you're talking about the smart bus stop?
Maybe Putuhari Gunawan, please speak, I guess. Oh, yes, sir. He answered.
Sorry, microphone is actually it's not good. So okay, so that's what I asked is about the video that I've what you showed before. It's about the buses, how to you said that I saw that in the system that the buses use the, for instance, the temperature or anything. So that what I want to know, that's about the data actually. Is it in real time, or is it actually you the model is already installed in the bus?
Okay. I try to answer your question. I'm not sure if it's so what you want to ask. Basically for this kind of system, okay. For modeling purpose, usually we deal with static problem. Okay. So we assume that we have the data. Then based on the data, we create mathematical model. We develop algorithm to solve the problem. Okay. But in reality, we need to divide the problem, actually divide the time into different time buckets. Okay. So for example, you take 5 minutes data. Okay. Data, look at the demand and supply, and then you quickly solve a static model. And you probably need to use a very fast heuristic algorithm to solve it, so that you can dispatch your truck, dispatch your taxis, okay, or make your delivery plan dynamically. Okay, so you need to solve for a smaller problem, okay, smaller static problem, but need to solve it really fast. Okay, so basically need to solve the same problem many times. And actually you just try to in some system, okay. For example, one of the systems that I designed, okay, I will listen to the event very similar to simulation. I will listen to the event. Okay, for example, one package have been delivered. Okay, or someone sent a package, or a passenger get off the taxi, or a bus just leave a bus stop. Okay, so I listen to this kind of event. Okay, then I was just temporarily freeze the time, take all the data, the real data, then solve a model, and quickly make a decision. Okay, and then I wait until, and then I continue to listen and see if there's another event. Do I need to resolve the system, the problem? And so this, so basically for modeling purpose or propagation, we're going to solve static problem. Okay, but for practical use, we need to solve many small static problems. Okay, yeah, of course, for real problem, you need real data. Okay. Yeah. Does this answer your question?
Thank you, Professor, for your answer.
Thank you, Mr. Yu. I hope Putu it answer your question. Does anyone have any question? Feel free to speak, I guess. Afif, can you help? Thank you.
Test. Thank you, Professor. My name is Dian. I am doctoral student in ITB. Your explanation is very good for me. And I have one thing that I want to ask you about the evaluating about the model. How to evaluating logistic innovation that already underway so that existing challenges can be answered and provide the solution. Thank you.
Could you repeat your question again? The first part?
Sorry, evaluating about the existing model that you make for bus stop, maybe the others model.
You mean how do I solve the model?
Not like that, Mister. But I mean, how you can make the evaluating about the model that you made. For example, for bus stop, for the first you made the model for optimization bus stop, and how to evaluating about the model.
How to? I mean, I have the model, and then how do I?
Maybe validation about the model.
Validation?
Validation.
Okay, I see. You mean so when after I build the model, how do I verify that the model is correct? Okay. Okay. Actually, it's quite difficult. Yeah, you build a model, right? Then you solve it, and most of the time the model may have some bugs. Okay, may have some bugs. So what you need to do is you probably can first you can manually verify the solution from the model. Okay, and then for the model you have a lot of assumptions, a lot of constraints, right? And then you to probably manually verify the solution to see if you violate some constraint or some assumption. Okay, there's no easier way to do it. You just need to verify it by yourself, and yeah, and then you probably can sometimes you can design test problems. You can design test problems that you know what is the optimal solution. Okay, and then use that to verify your solution. So this is probably easier than the manually verify the random solution for random test problems. And another way is to use another method to solve the problem. Okay, for example, you can design an algorithm and solve the problem by the algorithm, then compare solutions. Okay, you can use Excel to verify the correctness of the solutions. Okay, but basically, from my experience, we hardly make it right on the first try. Usually, you need to do a lot of modifications. And sometimes you can find it really fast. Sometimes you will find it after a month or two. After you develop algorithm and solve the problem, then you find out that why is this solution different from the solution from the model? And then you go back to the model, you find some problem in the model. So this is that's just hard work. Just hard work. Yeah.
Is it answer your question? Okay, thank you, sir. There's another question. This is the last one from Prof. Novriana Sumati, sir. She asked, Professor Yu, thank you for your interesting talk. She asked you a more detail on logistic transportation. What algorithm do you use for finding the shortest path? Do you use Dijkstra algorithm, sir?
Shortest path?
Yes, sir.
Shortest path? I'm not sure what you mean by shortest path. For us, we are not finding shortest path actually. Okay, we are finding probably the routes of the trucks or the route of the drums or the buses. Okay, for shortest path, our problem is much more complicated than the classical shortest path problem. The classical shortest path problem can be solved by many algorithms to optimality. For example, the Dijkstra algorithm, right? Yeah, which you can find in almost any textbook. But for us, okay, the problem is much complicated than that. We have for shortest path, you have one origin, one destination. You try to find the path of shortest distance, right? But for our problem, okay, first usually we have many vehicles, we have many trucks, so that's a lot of passes. Actually, not passes, tour like circles. Okay, you dispatch truck from your depot, right? And the truck need to come back. So it's like a bunch of cycles. And sometimes we minimize the total distance. Sometimes we also need to minimize the emission. Okay, and sometimes we are trying to maximize the profit. So the problem is very different from the classical shortest path problem. We have the much more complicated model algorithm. Yeah, and yeah. So I'm not sure if I answer your question.
With one. Okay, thank you, sir. I'm sorry, with one, we don't have any more time for your question. I guess that concludes this webinar Q&A session, sir. Now we move to the fourth part, which is giving certificate to Mr. Vincent by Professor Ujiana S. Pasaribu as the chairman of ITB Statistics Research Group. Prof. Ujiana, the floor is yours.
Okay.
Certificate?
Again, we would like to thanks to you, Professor Vincent, since you give a lot of new view and new idea for us, because for more than 4 years actually we haven't invited people from industrial engineering. So it is refreshed me like when I did my undergraduate and took some courses in industrial engineering. Okay, this is the symbolic of our certificate. Hopefully it is right, your name. I think it is right, yeah. Okay.
Okay.
Udah?
Okay. Thank you, Professor.
Thank you. Thank you.
Dear ladies and gentlemen, now we move to the fifth agenda, which is taking group photo with all of us. Please turn on your camera if you haven't turned it on. Okay. Udahnya. Have everyone turned on the camera? Oh. Everyone who haven't turned on the camera, please turn on your camera. We will taking photo together. Well, okay. Let's take a photo. 1, 2, and 3. Cheers. Once again. 1, 2, 3. Cheers. Okay, I guess that's the photo session. Dear and ladies and gentlemen, that concludes today's webinar. Thank you for your cooperation. And from the deepest of my heart, I do apologize for my mistake as the MC and moderator of this event. We hope you can join us again. Bye. Thank you.
Okay. Thank you. Bye-bye.
Bye. See you.